Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be taking a look at something called the Screenless Computer right after this. So I want to kind of talk about this today a little bit, to talk a little bit about what it is and what happened to it. But I suppose before we go there, technology a lot of times comes from dreams or maybe stories in a sci-fi book or literature, some idea that comes up that looks like it might be viable as a commercial thing. And as Casey said, dreams are today's answers to tomorrow's questions. Yeah, so I mean, if you look at some of the things like some of the early movies that depicted robots, for example, Metropolis way back at the turn of the last century. There was also 2001, in which HAL was a artificial intelligence that controlled the spacecraft, along with the communications and the environmentals for the systems in the ship. You also had Star Trek, which also had a computer that was interacted by voice. Had some displays and some interaction, but the main thing about that came out of that one was the communicator. That became the flip phone from Motorola. Star Trek Next Generation had a computer tablet, which became tablet computers later on. So a lot of the designs that we have come a lot of times from the things that influence us or cause us to be inspired. And one of the things, well, there's two of them, and people always put these together, user interface design and user experience. But they're really not the same, and they're not really directly related. They do have impact on each other, but they're really two different things. So the user interface, of course, is the layout of the application, how it looks. What's the form? What's the function? What text fields does it display? Where does it allow data entry? What kind of data entry? Does it have sliders? Does it have buttons? All the things and information that is needed to both convey information to the user and to accept information back from the user. On the other side of it, you have the user experience, and that is how simple is this thing to use? And more importantly, is it compelling enough to get my attention to bother to want to use it? Those are the kinds of things that go into the user experience. So they're not really related. They do play off of each other, but they're not related. So one of the things that I remember that people talked about 30 years ago was, how are we going to reduce the size of the machines? And most of the time they were talking about the desktop. How do I reduce that? I mean, if you look at your laptop, if you have one, half of your size of your laptop is the screen itself. And then you have a pretty large part of it, which is the keyboard, and another part of it, which is the battery. So those three components make up most of the size of the machine. The rest of it is pretty small. Same thing with your desktop. You have the machine itself, the box. You have a power supply, you have a graphics card, you have a motherboard, a CPU, some memory, and all that stuff. But then in order for you to get access to that machine, you need to have a screen, a keyboard, and a mouse. And depends on how many screens you have, that could take up quite a bit of real estate on your desk. And so there was a lot of discussion about how to reduce the size of these things. And yeah, some of it was circuitry, but most of it was how do we get rid of it? How to get rid of the keyboard, because without getting rid of the keyboard, there was no way we were going to be able to make things smaller. So there was some discussion around that. It kind of died out. And then in 2001, it came back up again. And in 2014, there was a lot more published about it. In 2017, there was a lot published about it. And in 2018, kind of a little bit more, but not much. And then it sort of went quiet. So I don't know if that's because it started to reach the point of being commercially viable and the research was really at a point where you could start launching products, or whether it There were some things tried and it died and no one was really interested. But what is it? So there's really three different ways of doing screenless displays. And we'll talk about it from that aspect first. The first is visual, but this is not a screen. Instead, you display an image on a piece of glass, maybe in the air, maybe in water, and if the water's calm enough, you can do that. Typically, they're holographic, and the advantage of holographic imagery, of course, is that they're three-dimensional. So you don't have to be sitting in a certain place to be able to see it. You can get up and walk around the image, and you can still see it from all angles. There's a variant of it called a heads-up display. That uses two pieces of glass to create the formation of an image that is displayed, that appears to display on the windshield. So, if a good example of that might be a fighter jet, it might be a car. There's some heads-up displays in cars, but a fighter jet comes to mind in that it displays situational awareness information to the pilot, as well as the orientation of the aircraft, the fuel status, the weapon status, whether or not they're under threat, any of that kind of stuff it displays to them. So those displays react to the user's behavior. So if I'm reaching out to touch something, there was a device that had cameras and infrared and cameras that would watch your fingers, and then it would allow you to gesture in the air. And it's stuff like that that allows you to interact with these holographic images. There's a pretty good video, and I'll see if I could find it, included in the show notes, about a holographic display in Dubai where a polar bear jumps out of the water, and there's a family that's standing on kind of a platform, and the polar bear jumps up, and they reach out to the polar bear, and it sits down, and they start to pet it, and it rolls over onto its back, and then they start petting its belly. It's stuff like that where the interaction of the system is taking place based on the behaviors of the user. A second type is a retinal display, and a retinal display doesn't need to, it's not like Google Glass, and it's not like augmented reality. It doesn't use reflected light to create an image on your retina. It actually has a projector that projects the image directly onto your retina so that your brain can then form the image from that information it collects off the retina. So the light isn't reflected, but you have a very private view of that information. No one else can see it but you. The third one is probably the most scary to me, and that is the synaptic interface. In this case, you're bypassing the eye, you're not using light. Instead, you're transmitting information that your brain can interpret into a visual response. So the synapses in your brain are firing to create information from this stuff that's being generated in your brain. This technology has been tested on humans, and in fact, there are some corporations today that are even using it. So how do they use this thing? It's been used in communication, education, business applications where they're maybe looking at goals and results and that kind of stuff. Also in security to open doors. You might hear this being called human-machine interface, synthetic telepathy. You might hear it called mind machine, or you might even call it direct neural interface. It is a little scary, but nevertheless, there you are. Those are the three major types. Microsoft had developed this table. I think it was. Well, let's see. It had to be in the late 90s, maybe early 2000s, but it allowed a group of people to work together on a project. And so they would have this display that was on the table, and they could move things around and create whatever it was they were trying to develop as a team. Apple had their iPhone at launch, and on that launch, they had a device that had a proximity sensor, a light sensor. It had a magnetometer and an accelerometer. So the device could respond to the light in the room and then adjust the display accordingly, so the user didn't have to do that. And the second one was if you were getting close to the phone, it would turn on and display the screen to you, or if you picked it up. The third one was the magnetometer. So I don't remember if you remember the compass application where you could just have the phone in your hand and then slowly turn around. It would show you the direction on the compass wheel, which direction you were facing. And then the accelerometer would respond to moving the screen around at different speeds, and then that would translate, if you were playing a game, to fast movement or slow movement, whichever. So, but they really didn't do a whole lot with that. It was more of a toy and a kind of a gimmick at first. Later on, they kind of developed it more into stuff. But one of the things that Apple didn't invent, but was that they have claimed they did, was multi-touch. And multi-touch was actually invented kind of by three different locations at once. It was one of those good ideas where everybody thought of it. So Bell Labs worked on it. Carnegie Mellon actually worked on it, and also CERN. There was three of them that did that. And there was some people that developed some things over the years. There was, I think, up until about 2018, there was a company that did a very advanced version of multi-touch called Qubit. And I don't know what happened to them, but their source code is out in the open source community now. So I don't know if they just felt that everything had been done that they needed to do, and there really wasn't any commercially viable place for them to make money. So they just put it out in the open source community, which is really nice of them to do that. Also, there's virtual reality kind of had, I think, three different starts and stop. Well, two stops at least. But there was some work that was done in the 80s, and those systems were big, clunky, expensive. Took a lot of power. Didn't do a whole lot. I mean, if you look at a movie called Lawnmower Man, you can see how the development of that technology at the time was pretty bad. Then in the 90s, they tried it again, added some additional resolution, some additional features to it, but it was still disorienting, made a lot of people sick after a while, and it really wasn't all that good, and then it kind of sat for a while. And then it came back, and in the second, I think it was the second decade of the 2000s, where people started looking at virtual reality again, and those devices were a lot better. But the real problem with virtual reality is that there's still people that get motion sickness from it. If the displays aren't keeping up, you can get disoriented and then have a feeling of falling, and that's never good. The other thing about them is that they are completely depriving you of your senses. If you're wearing the headphones, you lose your auditory senses, and if you're wearing the headset, you're losing your visual senses as well. So, yeah, I find that a little uncomfortable when I'm playing. If I had some virtual reality gear at one time, and it just didn't work out for me. I just didn't like it. Augmented reality, however, does not deprive all your senses. It allows you to continue to see the real world and hear in the real world, but they add additional information on top of what you're seeing. So they can provide information about where you are in relationship to the things around you. So they can tell you, for example, what is on the menu at the restaurant across the street and what the prices are, for example. So a little bit more tolerable, but those devices are very expensive. I know that Google Glass came out initially, and of course that's a defunct product now, but that was like $1,000 for that. And then Microsoft has their augmented reality glasses, and I think when they came out, they were $6,500 or so. They were pretty expensive. I don't know what they are now. I haven't not tracked it, but I just don't know. So, and then some of these features made their way into the mobile devices as well. Now, Apple doesn't require you to wear a headset to use augmented reality. They just mix the what's coming in from the camera with the application to create the augmented reality that you see on the screen. And then Adobe was working on several applications at one time, but I think they've abandoned that work. At least I haven't seen anything surface from it that could be viewed and used without an actual screen at all. So yeah, and so what's some of the advantages of screenless displays? Well, first of all, they use less power. They don't need to have turning on lights on a screen, so you don't have that energy loss there. Also, you can you can work with higher resolutions than you would normally be able to do by trying to generate that same or recreate that same image on a display. You can also get obviously a wider angle of view because you're kind of limited with a flat display. You can get better color if you're transmitting the image directly to the retina. There isn't any color loss in the translation of the reflection or in the reproduction of that image. You can also generate three-dimensional images, which would be really difficult to do with a display. The other one is far point images, and that has to do with the human eye. The eye is actually a far point imager. It prefers to stay in that state. And when you use a screen, you're forcing it into near point imagery, which creates strain. So you're trying to reduce the effects on the body. That's how I understand it anyway. I'm not a medical person, so if you are and you can explain it better, please leave a comment below. There is lower costs involved with it, and it also, because of the way that the screenless displays are assembled, they don't use the same kind of parts that a normal display would use, and so the toxic elements that go into the production of a screen display aren't present in the others, or it may be in a lesser amount than the others. We'll put it that way. But the biggest advantage is there's no user interface that's really required, other than your hands and your eyes and the ability to interact with it. Some of the disadvantages are like the retinal display or the virtual retinal displays, VRDs is what they're known as. They're not available in any sufficient quantity to be affordable. Let's put it that way, profitable or affordable. So prototypes and special experimental stuff has been around for a while, but I think the reason why we're not seeing a lot of those is just that there isn't a driving need to try to break the barrier of making them economically viable. You have to have, obviously, demand in order to make sure that you can drive the cost down. So there appears to be some development in this, but I haven't seen any activity lately, and maybe I'm just not looking in the right places, but I'm just not seeing as much as I did. So the biggest disadvantage here is that you still need some user interface in order for those types of devices to work. So the closer you get to the brain, the less user interfaces you need. But you still need to have something to turn on the display and be able to get it to display the information that you want. So yeah, there's still some user interface that are needed there. But the whole idea behind it is to reduce or eliminate the user interface itself, and thereby making it simpler and easier for the user experience. So hopefully you're making the user experience better. But there's lots of applications that kind of done this. One of them I can think of is Locket. Locket that was a cell phone app that had, I think it was a cell phone app originally too, but it allowed you to lock your door and then unlock it, but you had to go through a series of steps to do that. And I think they counted up 12 steps to go from locking your door to unlocking your door, all the things you had to do. So they went back and they redesigned the application and they added some AI so it knew that if you were approaching the door from the inside, they figured that you probably wanted it unlocked. And if you were approaching the door from the outside, you probably wanted to lock the door when you passed it as you were going out. But as you were coming back and on the outside coming in, it wanted to be unlocked. So they added some of that feature. So they basically went down to 2 steps that you had to worry about, lock and unlock it. There was also an application called Timely, which was trying to solve a problem that corporations were having, and that they thought they were losing money because if they were under contract and on billable hours, they didn't know if they were getting the full amount of hours to bill. And they estimated, I don't know, $50,000 per person per week or something they were losing in revenue. So Timely attempted to try to solve that. And they came up with an app which would basically force you to do the data entry. So the UI was horrible. I mean, in terms of, did it really benefit you to use the time card versus application versus Timely? Maybe if the problem that with most time card apps is that everybody waited till the end of the week to do it, and then no one could remember what they did during the week, and then they remember exactly what they did or exactly how many minutes and hours that they spent. Whereas if you did it all along with Timely, your accuracy would be better, but it was more painful because you were doing more entry to get it into the system. So yeah, it just wasn't very good. And so they went back and they added an AI to bring the application up, and then it would record what you did, and then it would log the amount of time. So it built the time card for you in the background with as least amount of input from you as possible. So a much better application. Uber is another one, but Uber, you're not free from the UI completely because you still got to set up the ride. But once the ride's over, you hit the button that it's done and it pays the driver. You're done. You walk away. You don't have to get out a credit card. You don't have to wait for it to clear. You don't have to wait for all that nonsense. And I don't know how many times they in taxi cabs, instead of reading the card, they'll just take it and swipe it, and then through the reader, and then they'll hand you the paper receipt, and then that's it. And that takes so much time. Weather apps, of course, use the GPS and the time of day to figure out what the weather is at your location. Of course, if you're standing outside, probably a pretty good chance you know it's raining. Maps, same thing. It knows where your location is based on your GPS location, and then all you have to do is provide it the destination to get the rest. Some other examples are Google Assistant. I know there's also Siri as well, but I don't think Siri is as well developed as some of the others. But Google Assistant will provide you information. It'll provide search information. You can shop in a limited format with it. Amazon Echo is a little bit better in that regard. We can shop. It'll read books to you. Now, Google will read books too, but unfortunately, none of these players overlap their applications willingly with one another. So, yeah, so if you're wanting Kindle book readers, you got to go to Amazon for that. If you want Audible readers, you got to go to Amazon for that. So, and then you can play music on both of them, or you can schedule appointments or whatever else you need to do, get directions verbally. So, the other part of it is there's also the watch interfaces today too from a number of different companies, where it will take information and allow you to keep that device in your pocket, but it'll give you the equivalent of a heads-up display while you're out and about or in a meeting. Maybe you're driving your car and you just want to glance down and see what it was that someone wanted. But there is also now applications that are offered, at least by Apple that I know of, that will allow you to disable the notifications and the phone pretty much while you're driving. So you can tell it not to disturb you while you're driving. So I think those are good things to have, because the studies have shown, using your phone is the same as being drunk. So legally drunk. So yeah, you're not a very good driver if you have the phone and you're reading that. So, but anyway, I'm going to leave you today with a quote by Golden Krishna. He's the UI designer for Google. I don't know if he's still there. I know that he was a couple of years ago, but he said the best interface is no interface, and he's right. I mean, you want it to be as natural as possible. We're trying to get to the point where we don't need screens, we don't need keyboards, that we can interact with the devices using the same way we interact with each other. And maybe by doing that, we'll get back to interacting with each other instead of interacting with each other through screens, because that has a different psychology behind it. And you really, in a social environment, you want to be able to interact directly with people. That creates a better human experience. in my opinion. So that's all I had today. I hope you enjoyed this little talk on screenless displays. It's kind of an oxymoron, isn't it? Screenless displays. You still have to have information displayed somewhere, right? But the idea is to try to reduce the UI. That's the only thing to it. Hope you enjoyed this. If you did, please like and subscribe. Hope to see you again real soon. Bye for now.